Hello YouTube viewers, welcome back to my channel. I'm Sri Tips, and today what we're going to do is we're going to construct and operate the electrolytic gold refining cell. And we're going to do that right now. Here's our chloroauric acid solution that we'll be using for the electrolyte. It's got 160.5 grams in 470 milliliters of solution. That gives us 0.34 grams of pure gold per ml of solution. What I'm going to do before I get started here, I'm going to put it up on this scale and weigh the bottle with the solution in it. And if you notice right here, I put a little mark where the solution volume is so we can duplicate this later. What I'm going to do is, everybody's curious whether this solution weighs more with gold in it than without gold. And I don't know if it's an accurate comparison, but what we'll do is fill it back up to that level with water later on and weigh it again. So we've got 900.8 grams of the weight of the bottle with the solution in it. Here's what I've selected as an anode bar here. This is just about 1 troy ounce, just a little under 1 troy ounce of pure gold. And we're going to use this as our anode bar. This is our cathode that we made from a 999 fine gold coin. And I'm going to try to flatten this out a little bit more to get it to the required spec of 3/1000ths of an inch. Right now it's about 7/1000ths of an inch, and so we're going to try to flatten that out a little bit. And I was trying to determine which beaker to use for this process, the 400 milliliter or the 600 milliliter. If you look down here at the description of the process, it says that cathode starting sheets of fine gold rolled to a thickness of 3/1000ths of an inch, having an immersion area of 12 by 2, are suspended in rows of 4 from silver cathode rods between the anode bars. But it does not give a specification for the distance between the anode and the cathode. And so I'm assuming that they're going to be pretty close. So I think what I'm going to do, plus it'll save on the electrolyte level, what I think I'm going to do is go with the 400 milliliter beaker here and suspend the cathode on one side and the anode bar on the other in the electrolyte. All right, here we go. I'm just going to fold this cloth over on it and pound on it for a few times here. See if we can get it flattened out a little bit better. See if that made a difference for us. Yeah, it made it bigger. Here's our cathode foil. It's just a thin foil of gold here. And I've kind of bent it to fit the contour of this beaker here. And kind of folded a little flap over the edge. And I can I got a copper clip here. The book calls for silver, but all I have is copper. I don't have any silver. But anyway, I could either clip it on like this, and it's nice and sturdy, it ain't going nowhere, or I could clip it like this. There's a little tongue hanging over here, and that way I could put a cover on top of it as the cell operates. So we'll see when we get to that point. All right, I've chosen to use a 250 milliliter beaker here. It's a little bit better size given the size and shape of our cathode and anode. And what I'm going to do is I'm going to run this down to the jeweler's now and flatten this bar a little bit in his rolling mill. And then I'm going to get him to solder this piece of 14K gold bracelet scrap onto the top of the anode bar, and then we'll be able to hang it in the cell and cover it up. This is the jeweler's rolling mill, and it's 2 steel rollers there, and I run the gold bar through it over and over, and I tighten the rollers together just a little bit each time I run it through there. There's a little hand crank on the side that I turn, and it will flatten that bar out for us and give us some more surface area. Here I want to get a weight on our anode bar. And what do we got there? We got 25.7 grams. Before we try to solder this together, I got to get everything real clean. So I put it in the ultrasonic cleaner and then steam it off real good. And then we got it over here on the jeweler's block here. He's got some solder paste and solder chips on the piece of 14K gold wire there. Notice how he's applying the heat to the gold bar because it's very thick. It will absorb a lot of heat, and so what that'll do is it'll heat it up and then transmit the heat through the paste into that 14K piece. Just got back from the jeweler's. He soldered my gold anode bar onto this piece of gold wire here. It ain't going nowhere. He's got it on there good and tight. And so what we'll do is we'll fashion it so that it hangs into our cell like this, and then droop the wires over the edge so that the cell will stay in place, or so that the anode will stay in place. And then we'll put our cathode on the other end. But before we assemble the cell, I want you to look over here at this gold crystal that's forming in the bottom of that jar there. I couldn't quite make out what that stuff was. Wish you could see it in person, man. It's just absolutely gorgeous. It's pure gold, metallic gold crystals forming in the bottom of that electrolyte. Just beautiful. And they're really neat looking. I wish you could see it in person. Video doesn't quite capture the beauty of these crystals. Some metallic gold crystals coming out of solution in that highly concentrated electrolyte. All right, I'm constructing the cell here. I've got the anode bar hanging down in there. I'm going to use 200 milliliters of electrolyte. And so what I want to do here is make sure that the anode bar at the 200 milliliter level is just hanging down into the electrolyte. I do not want the 14K gold wire getting in the electrolyte. So I think I got it set just right here. Now I'll be able to put the cover on it and keep junk out. Man, we're ready to set this thing up and start making some pure gold crystal. Here's my calculations. I've got a solution in this jar right here that's 160.5 grams per 470 milliliters of solution, giving me a concentration of 0.341 grams per milliliter. What I'm going to do is add 100 milliliters of this solution to the beaker, and what that'll give me is 34.1 grams of pure gold in the 100 milliliters of solution. Then what I'll do is add 80 milliliters of distilled water to bring it up to 180 over here. And then I'll add 20 milliliters of hydrochloric acid to give us the 10% of hydrochloric acid that we need for this electrolyte. I'll have a total of 200 milliliters of electrolyte with 34.1 grams of pure gold dissolved in it. That's 1/5 of a liter. If we take 34.1, multiply it by 5 to get a total of 1 liter, then what we'll have here is an electrolyte solution with concentration of 170.5 grams per liter. 170.5 grams of pure gold per liter of solution. That's in excess of what the book called for, but I think that'll improve our chances of getting a successful outcome for this experiment. Okay, even though these were very elementary calculations for the electrolyte concentration, I had to call my good friend, Dr. Paul Young, math professor at the College of Charleston, and run those figures by him to make sure that I was doing it right. And he confirmed it for me, and they're correct. But what I did is I included a link to one of Dr. Young's videos in the description section of this video. And if you would, go down there, click on that link, watch the video, and see if you can tell what he's talking about. He's using English words, but it may as well be Greek. Dr. Young is one of the smartest people I've ever met. He's a good friend of mine. While you're there, if you go look at the video, while you're there, click on the subscribe button. Let's see if we can help him out with a few more subscriptions. All right, we're getting ready to start the experiment here. I've got our cell set up. It's a 250 milliliter beaker. Got the gold anode bar hanging in there. This is the cathode, made of high purity gold also. And I've got the negative lead connected to the power supply back here. And I've got the positive lead connected to the anode bar through that piece of a 14K gold wire. Now what I'm going to do is I'm going to mix up the electrolyte in accordance with these instructions right here that we wrote out earlier. Before I do that though, what I want to do is I want to transfer this electrolyte to this big beaker. If you look in there, as I twirl this around, you can see there's some different densities of liquid going on. So what I want to do is get this all homogenized. So what I'm going to do is I'm going to pour our solution into this big beaker here. Here's a look at that gold crystal in the bottom of that jar there. Man, that stuff looks fantastic. I don't know if that's chloroauric acid solution that came out of solution there and formed those crystals, or if that's metallic gold. It's got a glint to it like it's metallic. I can't tell. Anyway, what we're going to do now is we're going to leave the solution concentration just like it is. And now I've got to transfer it into this beaker so we can give it a quick swirl here to get it all mixed up real well. I'm going to pour the electrolyte in now to the 100 milliliter level. Carefully. There we go, that's 100 milliliters. Alright, now we're going to put a stir bar in, brand new stir bar, nice and clean. Start the stirring. Turn some heat on here to start heating this thing up. Now what we'll do is dilute the electrolyte down with some distilled water I have here. I'm going to try to fill it up to about the 180 milliliter level in our experiment here. Distilled water going in now to dilute the electrolyte. hydrochloric acid here. I'm going to add 20 milliliters of hydrochloric acid now for the 10% that we need for this. Careful not to go over the top of that anode. About right there. I've got our electrolyte mixed up. I'm going to crank the stir bar here because you can see the two different densities or three different densities of liquids in there. So I'm going to get it all stirred up real good before we put some power to it. Make sure we got a nice mixed solution there for the electrolyte. Try to get that little piece of trash out of there. Got him. Got him. Alright, at least we got that out of there so we can proceed. I've got 10 minutes to 1. Look at the temperature there. We're at 143, so I'm going to cut this down just a little bit, the heat. Now I'm going to slowly apply some current. I've got the current knob set straight up to nothing, and I'm going to give it a little bit of juice here, voltage-wise, to see what kind of readings we get. It's 1 volt. Amps, over 3 amps going through that. 1.5 volts, that's about where we want to be. That's what the instructions call for. Suggested right here. 1.5, that's what we want to leave that. About 1.5 volts, we got 3.9 amps flowing through the cell. Let's see what happens. Oh, it's turned color. It's turned a different color. In there, I don't know if you can see that. It's turned black. I don't know if it's supposed to do that or not. We'll just let this run now and see what happens. Time is 2:15, so we've been running almost an hour and a half now. If you look in there, you'll see that we got some gold building up on that cathode. And the anode's getting real skinny. Starting to corrode away completely. So this looks like this experiment's going to be a success here, man. I'm going to try to keep it close to 140. It's at 148, a little high, but apparently it's working okay. Time is 20 minutes to 4. So been on just under 3 hours. The anode has completely corroded away. And if you look down in there, you've got pure gold built up in the cathode. The solution is completely, or the current is completely gone down to zero. What we're going to do now is turn the heat off, turn the stir bar off. We're going to disconnect the leads now. We'll pull this down off the heat. Let this cool off, then we'll get in there and take a look at our gold crystal. Okay, I think this experiment was a success. Let's get our gold out and take a look at it here. I was how should I say, pleasantly surprised, kind of flabbergasted, I guess you could say. I came back out and the anode was completely gone. Here's our pure gold crystal. I'm going to take it, put it up here in this clean beaker. I'm going to rinse it off. Get all the electrolyte off of there. Get rid of this clip. All ultra high purity gold here. Really doesn't look like crystal compared to silver cell, but this is high purity probably close to 4.9's fine here. My goodness. You know what it reminds me of? A morel mushroom. Stuff is absolutely amazing, man. This is just incredible. I didn't realize it was going to work this good. Alright, what we'll do is get this out now, dry it off, get it weighed, and I'll figure out what to do with it after that. Look down in the beaker down here that we had the reaction going on. There's still a little bitty piece of gold down at the bottom down there. And what I'll do is with the electrolyte that's left over and the electrolyte in the big beaker that we didn't use, I'll just gather that all up, filter it, and drop it with SMB. But man, nice. Okay, here's our pure gold crystal. That stuff really looks incredible. And I want to complete the experiment that we started earlier. I had this jar full of the gold solution, remember? We got to wait on the jar and the gold solution with the level at that mark right there. So what I'm going to do is rinse all the gold out of here into this beaker. Then we're going to fill this jar up to this level with just water and weigh it and see what the difference is. You'll recall at the beginning of the video, I had this glass jar full of the chloroauric acid solution that I used for the electrolyte. I marked the level right here, put a little mark there. And now I've completely rinsed the bottle out of all the gold solution and filled it full of distilled water. So now what we're going to do, the jar and the liquid with the gold in it weighed 900.8 grams. And now I've got the jar to the same level as I had it before, same volume. With distilled water, we're going to put it on the scale here and see what we got. Looks like 677.3 grams. So the gold in solution weighed 900.8 grams, and with the same volume of water, we only get 677.3 grams. Here is our pure gold crystal. I've dried it off. Now we're going to throw it up here on the scale and see what it weighs. We've got 27.7 grams of absolutely pure gold. The book says this should be about 9997 in purity. All right, here's our gold, pure gold crystal that we've grown in our electrolytic cell. Very fascinating looking. It's glued to that cathode piece very firmly. It's not crumbling off or anything. But I suppose if you bent it, it would crumble and fall apart. Now what we're going to do is we'll put it on here on this anvil. And we're going to stamp 3 tips on there. Here we go. Yeah, you got it on there. 3 tips. Well, this one came out way better than I thought it would. I did not know what to expect. I didn't know if I was going to be able to pull this off or not. But this thing just came out looking incredible. It's probably close to 4/9 fine, pure gold. Looks like a morel mushroom to me. And it weighs 27.7 grams. And what we'll do, I stamped 3 tips on it. What we'll do is offer this up for sale on my eBay store. The remnants out there, all the solutions that I still have left, the electrolyte and the electrolyte solution that I did not use in the rinse water and all that, all will contain gold. And what I'll do is I'll put that all in one beaker and then precipitate everything out with SMB and gather that gold back up and melt it up into a bar. I guess that's it for this video, man. This thing is a work of art. It is absolutely highly unusual looking. So we're going to offer this up for sale on my eBay store. This will conclude the video. Thanks for watching.